Excuse me. Hello students, good evening all. So welcome to our next session of topic statistics. So we have already had one session in this topic of statistics. So where we have started discussing with the introduction part. So this is our second session. So I hope you guys don't have any questions, any doubts from the previous session of statistics. So if you guys have any doubts, any questions regarding the first session, you can please let me know so that we can just clarify that doubts before starting our session today. Okay, so far no questions. So we'll just continue with the today's session. So before starting our today's session, we'll just have a quick recap of the topics that we have discussed in our first session of statistics, and then we'll just have a brief introduction to the topics of our today's session. So in our previous session, we started with the introduction part of it, and then we have discussed different types of series in which we have discussed individual, discrete, as well as the continuous series. So 3 types of series. And then after the series, it's followed by this mean. So for even this mean, median and everything, so for each of types of series, we'll be having different approach to find the mean, median as well as the mode of a given data, right? So that's how we have done for mean. So we have seen how to find mean of these 3 typical series which we have discussed in our first session, right? So even we have started with this median concept. So we have finished the median, how to find when we have a individual series, when we have a discrete series. So for these 2 we have already finished. So today's session will be starting with this median for our third type of series, which is continuous series. Right, so we are going to start with this median of continuous series, and then it will be followed by the mode. So even for the mode, we are going to discuss for each of the series, like the individual, discrete as well as the continuous series. Right, so after the mean, median as well as mode, the next topic, which is the new one that we are going to discuss in our statistics, will be the mean deviation. Right, so in order to find this mean deviation, we'll be having different approaches. So we can either find using a mean, we can either find using a median. So we are going to discuss both the approaches in our session while discussing the concept of mean deviation. Right, so as I mentioned, we are going to start with this median concept in our today's session. So let's start with that. Okay, so let me keep it this way. So did anyone remember how we have found out the median for the individual series as well as the discrete series? So does any formula which I have given for both of these series, can anyone? So at least you can just tell me what are the steps that we have figured it out in order to find this median. What are the steps we have followed here in order to find the median? At least you can tell me for this individual series, because that's the very easiest one. Okay, so For individual series, in order to find the median, first we have to arrange the given data either in the increasing order or the decreasing order. Then we have to pick the middle term. If we are having odd number of terms, then directly the middle number will be the median. If not, if there are even number of terms, then we will be having two terms in the middle, which we have to take the average of those two. That will become the median of the given series. Right, whereas for our discrete series, we have to find our capital N, which is the sum of all the frequencies, and then we have to find the value of n by 2. So while discussing this discrete series, we have used a new term, which is cumulative frequency. So I have already explained how we actually find the cumulative frequency, and then after finding this cumulative frequency and n by 2 value, we have to check the value of cumulative frequency, which is just more than this n by 2, and the corresponding x value will be the median of the given data if in the discrete series. Right, so these two we have already finished. So now we are just discussing our next series, which is the continuous series. So this is the median form. Okay, so like how we are having a cumulative frequency in our discrete distribution, so the same way even in the continuous distribution we have to find the CF, that means the cumulative frequency as well as the n by 2 here. So, but here there will be a slight difference from our discrete distribution, because here first we have to find the median class. So the first step while finding the median when the distribution is a continuous distribution, the first step will be figuring out the median class. So now the question is how we'll be finding the median class. So we are going to find this median class like how we have find out the median in our discrete distribution. Right. So first we have to find the cumulative frequency. Right. And then we have to find the n by 2 value. Right. And we have to find the cumulative frequency. That means the median class will be the class, because here continuous distribution, in the sense it will be given in terms of intervals, which means it is in terms of some classes. Right. So first let me write down the steps here. First step will be figuring out the cumulative frequency and finding the n by 2 value. So why we required these two steps? In order to find the median class. So cumulative frequency and n by 2 value, using those two we are going to find the median class here. So now we are having the cumulative frequency as well as n by 2. So we have to check the class where the cumulative frequency is just more than this n by 2. Just more than, right? So we have to find the cumulative frequency. That class will be the median class where the cumulative frequency is just more than the n by 2. So that class will be considered as median class. So once we have this cumulative frequency and n by 2, the second step will be predicting the median class. And now if we have the median class, we can directly apply the median formula here. The median formula for the continuous distribution data is given to be L plus H by F into capital N by 2 minus C. So let's see what actually L and H, F and C defines here. So L is nothing but the lower limit of the median class. So we'll be having the limits here. One will be upper limit and the other will be the lower limit. So L here states the lower limit of the given median class. So that's the reason why the second step will be predicting the median class of the given continuous distribution. Right. So here L states the lower limit of the given median class. And here F is the frequency. Here F is not the cumulative frequency, it is simply the frequency of the median class. Right, so F is the frequency of the median class and H is the width of the median class. So width in the sense, so sometimes our intervals, our median class will be, our class will be 0 to 10, 10 to 20 like that. So sometimes it can be 0 to 50. and 50 to 100, something like that. So here what is the median width of the median class? So here the width will be 10, whereas in this continuous distribution the width will be 50, right? So here L denotes for the width of the median class, and N, we know what is N. It is the sum of all the frequencies divided by 2 minus capital C. So here capital C is the cumulative frequency of the class preceding to the median class. So it is not the cumulative frequency of the median class, it is the cumulative frequency of the preceding median class. So for suppose here 10 to 20 is my median class. Then what is my capital C value? My capital C value will be the cumulative frequency of my upper class here, that is 0 to 10, because 10 to 20 is my median class. The preceding class here will be 0 to 10. So that for that class cumulative frequency will be capital C here. So this is the formula which will be applicable here in order to find the median when the distribution given is a continuous distribution. Right. So now as we have understood how to find the median class and what are the elements which are present in the formula of the median. So let's do a question here related to the continuous distribution of median. So here comes the first question, guys. So let me write the formula here. Okay, let me write the steps. So first step will be cumulative frequency and n by 2. And next we have to predict the median class. We have to find the median class. And then finally median. So what is the median formula? So L plus H by F n by 2 minus C. So this is the median formula for a continuous distribution. So now the first thing is find the cumulative frequency. So we know this is our Xi and this is our Fi here, number of workers. So here I am just drawing one more. So this is not the Xi, so we have to find the Xi2 because it is a interval. Right, so first thing you can find the Xi. I think here no need of Xi, we can directly find the cumulative frequency. So this is not our mean, right? So there is no need of this Xi here. So we can directly find the cumulative frequency and using that we can find our median class. So find the cumulative frequency here quickly. As well as you have to find the capital N value, which is the sum of all the frequencies here. So take 1 minute and quickly find the cumulative frequencies and sum of the frequencies, guys, fast. So that we can find the median class here. So please let me know if you have any doubts while finding this cumulative frequency or the frequencies. So let's find out the cumulative frequency first. So here 15 for the first class, and 40 plus 15, 55, and 55 plus 50, right? So it will be 105, and plus 60 here, so 165, and then plus 45, 210, and then 210 plus 40, which is 250, and then plus 15, which is 265. So this is the cumulative frequency corresponding to the each of the class interval, and then we have to find the number of workers. So number of workers is nothing but the cumulative frequency. Our sum of all the frequencies is nothing but the cumulative frequency of the last class, which means 265. So now here we have to find the value of n by 2, which is equal to 265 divided by 2. So 132.5. Right, so here we have to find the cumulative frequency, which is just more than this 132.5, which is 165 here, because 105 cumulative frequency is less than 132, and 210 is way greater than, because in between these two we are having 165. So 165 is the cumulative frequency which is just more than the value of n by 2. So what is the corresponding class here? The corresponding class is 80 to 89, which means this class will be considered as the median class. So now as we have find out the median class here, so we can figure out the remaining values in our median formula. So let's see what is L here. So L is the lower limit, right? So L is the lower limit. So let's see the L here. And what is the H value? H is the width. So width here is equal to 10. So let me write down the values here. So H is equal to 10, and frequency of this will be equal to 60. And we already know n by 2 is equal to 132.5. And see cumulative frequency of the preceding one. That means this is a median class and the preceding one is 105. And L here is the upper limit or lower limit. So L here will be lower limit, so which is equal to 80. So these are the values according to the given data. So H with the width will be 10, and frequency of the median class 60, and by 2 132.5, and the cumulative frequency of the preceding class will be 105, and L, the lower limit of the median class, will be 8. So next we have to just substitute all the values and find the median. So let's do the calculation. So 80 plus 10 by 60, 132.5 minus 105. So it will be 80 plus. So do the calculation, guys. 132.5 minus 105. It will be 27.5. And here we are having this part division. So divided by 6. Around 4.6. So here M will be equal to 80 plus 4.6, which is equal to 84.6. So if they have in the options, if there is a round figure, then you can just round it to be 85, or else you can just if there is exact value is given, then you can just mark it the exact value, that is median here is equal to 84.6. So I hope now you understand how to find this median class and the median of the given continuous distribution. So let's do one last question based upon this model, and then we can move on to our mode. So give it a try, guys, quickly. So here they haven't directly mentioned in terms of intervals, but based upon the information and the question, you can convert that into the class intervals format. So read the question and check the tabular form which they have given and identify which type of frequency they have given, and based upon that you can form the continuous distribution table. So if you have any questions regarding this, you can please let me know in the text box. I'll be just checking that. So far no questions, guys. So I hope you guys are getting the concept clearly. So if you could able to convert this, then you're almost you have almost understood the concept here. So let's read the question. So a survey regarding the heights of 51 girls. So the total number of girls here are 51 of class 10th of a school was conducted and the following data was obtained. Find the median height. So here 51 girls height has been measured in centimeters, which is given here. So less than 144 girls, less than 145 11, less than 150 29, less than 155 40, and less than 160 46, and less than 165 51. Which means you can identify that the given information, the given frequency here is nothing but the cumulative frequency. So now we have to find the frequency as well as the class. So how you can divide the class and you can find the frequency here from the given table of cumulative frequency. So quickly guys, convert the table and find the frequencies and intervals. So let's find the frequency here. So here we can see less than 140, 4 girls, which means here frequency will be 4. So here we can directly take less than 140. So now here they have given less than 145, which means it has been included this 140 also. So if I want to break this from 140 to 145, then my frequency in this interval will be 11 minus 4, which is 7. Right, so same way we can break it the next interval also, which means here it is mentioned less than 150. So I can break it again from 145 to 150. So like here I can break it from 150 to 155. Here 155 to 160. And here 160 to 165. So here they have mentioned 4 girls are having the height less than 140 and 11 are less than 145, which means 140 to 145 height girls will be 11 minus 4, which is 7. So same thing here, 29 minus 11, that means 18. And here 40 minus 29, that means 1 and 1, 11. And then 46 minus 40, so here 6. And 51 minus 46, it will be 5. So now we have converted the given tabular form in terms of our continuous distribution, that is in terms of frequency and the class intervals. So now we know the methodology to find the median height here. So follow the formula and procedure and find the median height for the given continuous distribution. Here, so cumulative frequency is already given. So first step here will be finding the median class and then applying the formula, that is median equal to L plus H by F into N by 2 minus C, the formula of the median. So let's find out the median class. So we have to find the cumulative frequency, so N by 2. So N here is equal to 51. So 51 by 2, 25.5. So now check the cumulative frequency, which is just more than 25.5. So just greater than, which means 29 is the just greater more value than this 25.5. So the corresponding class interval is 145 to 150, which means this will be the median class. So once we have the median class, so let's figure out the remaining values. So lower limit of the median class here 145 plus what is the width? So 145 to 150, that is H value, which is the width, size will be 5. and frequency of this median class. So corresponding frequency is 18. And n by 2, just now we have found out the value of n by 2, which is 25.5. And C is the cumulative frequency of class preceding to the median class, which is 11. So we got all the unknown values here. So just now we have to simplify it now in order to find the median of this given continuous distribution. So 25.5 minus 11 will be around 5 by 18 into 14.5. So 14.5 into 5. So around 70 divided by 18. So that will be around 4. So here 145. So 145 plus 4 will be 149. So the average height, that means, the median height here. So it's not average. So the median height we are having here is 149 centimeters approximately. Right. So that is the median here of the given continuous distribution. So this is how we'll be finding the median of any given continuous distribution here. So now, as we have done with our median as well as mean of any of the different distributions, so now let's discuss the mode. So let's enter into the mode. So here let's start with the basic definition. So before stating the definition, I hope you guys have already known this mode. So can anyone describe in your own words what is the definition of this mode in simple words? So come on guys, quickly. Okay, so as I have already defined this mode while discussing our introduction part. So basically the definition of mode here is nothing but it is the value which actually repeats the maximum number of times. Right, that means we can say the maximum value of the frequency, the highest frequency value will be the corresponding value will be the mode. So the value which has the highest frequency, which actually states that the number of times it is repeating itself. Right, so in simple words we can say mode is nothing but the value which repeats itself by the maximum number of times. So for example, if I am having 2, 5, 2, 6, 3, 2. So amongst this, from this given information, what is the mode? So mode will be obviously 2 because 2 is the value which repeats the maximum number of times in this given set of data. Right. So this is the example of an individual series. So for any individual series, you can actually find the mode value by checking the frequency of each of the value. Right. So if it's in a discrete series, so in the discrete series, the frequency will be always given. So in that series, by inspection itself, we can state the mode for that given data. Right. So whereas when it comes to the continuous series, we will be having a separate formula to find the mode of the data. Right. So first our individual series, you just have to find the frequency of each of the value and check what for which value the highest frequency. So the greatest the frequency, the corresponding value will be the mode of the data. And the similar way for discrete, there will be the frequency which is already mentioned in the question. So by just inspecting the given information, we can determine the mode of the data. But that's not the case when it comes to the continuous series. Right. So now the question is how we will be finding the mode for a given continuous series. So in order to find the mode, the first thing we have to find is the modal class. So like how we have done for the median, so here we have to find the modal class. And here this is the formula which is applicable in order to find the mode of a given continuous series. Right, so let's see what are the variables here and what actually stands for the each of the variables here. So here the formula for mode in case of continuous series is equal to L plus F1 minus F0 divided by 2F1 minus F2 minus F0 into H. So L, as I mentioned, here we have to find the modal class. So L is the lower limit of modal class. So in our median, L is the lower limit of the median class, whereas in a mode process, L is the lower limit of the modal class. Right. And then that is the class having maximum frequency. So the class which is having the maximum frequency, that will become the modal class, and the corresponding lower limit of that modal class will be L here. Right. And then we are having another variables F1, F0 and F2. So F1 is the frequency of the modal class. So directly frequency of the modal class. Whereas F0 is the frequency of preceding modal class. Right. So frequency of the class which is preceding, and F2 will be the succeeding class. So frequency of the class succeeding the modal class, and H we already know that is the width of the modal class. Right. So this is the formula which we'll be using, and what stands for what, that we have already discussed. So the mode formula in order to find the mode in case of the continuous series will be equal to L plus F1 minus F0 2F1 minus F2 minus F0 into H. So this will be the formula in case of continuous series to find the mode. Right. So now as we have seen our formulas for each of the series in all these, for all these mean, median and mode. Right. So now we'll just see the relation between mean, median as well as mode. So the relation between mean, median and mode here is equal to, so mode here will be equal to 3 times the median minus 2 times the mean. Right. So there might be a questions where the mean is given in the question and you have to find mode. So at that time, mean and median both might have been. So amongst these two unknowns, there is a chance that 2 must have been given and you have to find the other one. So there you can actually use this relation between these three, mean, median and mode, in order to find the unknown value. So mode, the relation between these three will be here equal to, so mode here will be equal to 3 times the median minus 2 times the mean. Right. So now as we have seen the mode formula as well as the relation between these three, so let's solve a question based upon this mode. So first one is the very easy. It is the given series. The given data is the individual data. So quickly find the answer here. So mode of the given data. So the given data here is an individual type of series. So let's see the question. So the mode of the given data 7, 6, 10, 5, 9, 3. So what is the frequency of 7 here? So 1, 2 and 3. So it will be 3. For 6 it will be 1. And then 10 it's again 1. And for 5 the frequency is 1 and 2. And 9 frequency is 1. And 3 also frequency is 1. So what is the highest frequency here? 3 is the highest frequency. And what is the corresponding value? So the corresponding value is 7. So the mode of the given individual distribution is equal to 7 because the frequency of the 7 is highest amongst the given data. Right, so it's very easy when the given data is an individual series. So let's move on to the next question. So here comes the next question, which is given in terms of continuous distribution. So read the question carefully. So whenever we are having a continuous distribution and whenever we have to find the mode, so like a median, here we have to find the median class. Sorry, in median, how we'll be doing the median class? So in mode, we have to find the modal class. So how we are going to find the modal class? So modal class will be the class which will be having the highest frequency. So identify the highest frequency in the given data from the given data and identify the corresponding modal class. So let's read the question here. So a survey conducted on 20 households in a locality by a group of students resulted in the following frequency table for the number of family members in a household. So find the mode of the data. So here a survey has been conducted on 20 households in the locality. So now here they have resulted the frequency table for the number of family members in the household. So now we have to find the mode of this given data. So the family size here is 1 to 3, 3 to 5, 5 to 7 and 7 to 9, 9 to 11. And corresponding number of families here, which is the frequency 7, 8, 2, 2, 1. So in order to find the mode of this given data, the first step we have to find is the modal class. So how we will be finding the modal class? The class which will be having the highest frequency is considered to be the modal class. So identify the highest frequency. So amongst the given frequency, what is the highest frequency? 8 is the highest frequency, which means the corresponding class will be the modal class. So 3 to 5 here is the modal class. So now let's write down the formula here of the mode. L plus F1 minus f0 divided by 2 f1 minus f0 minus f2 into the width h. So let's directly write here. So L is the lower limit of the model class. So this is the model class. The lower limit is 3. So 3 plus f1 is the frequency of the model class. Right. So frequency of the model class is 8. And f0 is the frequency of the preceding model class. That means 7. Divided by 2 into f1 is the model class frequency. So 2 into 8 minus f0 preceding frequency 7 minus f2 which is the succeeding class frequency, that means 2 into what is the width here. So 1 to 3, 3 to 5, 5 to 7, the width here is 2. So h value will be 2. So let's simplify this. So it will be 3 plus 8 minus 7, it will be 1 in the numerator. In the denominator, so 1 into 2, we can directly write it 2. And in the denominator, 16 minus 7 and 2. So it will be 16 minus 9, which is 7 in the denominator. So now the mode here will be equal to 3 plus 2 by 7. So we just have to calculate the value of 2 by 7. So it will be obviously in decimals, around 3 plus 0.28, which means mode will be equal to 3.28. So in questions they might have mentioned that up to these 3 decimals, 2 decimals. So accordingly you can write the decimal places when the question is given. So here the mode of this given data will be equal to 3.28. So it's very simple when we find the model class and if we remember the formula of the mode correctly. Right. So this is all about mode. So we have finished mean, median as well as mode for all the 3 different series. So what are the 3 different series, which are the 3 different distributions of data? So the first one is individual series of distribution, second one is discrete series of distribution, and the third one is continuous series of distribution. So for all these different distributions, we have seen how to find the mean, median as well as the mode. So, right. So let's move on to our next concept, which is the mean deviation. So some of you might have learned this mean, median and mode in your lower sections only. Some of you might not. So but this mean deviation is a new concept for all of you. So let's see what is this mean deviation and what is the formula here. How we are going to find the mean deviation. Right. So if there are set of values which are given, that is x1, x2 and on that is which is in terms of our individual series of distribution, then how we are going to find the mean deviation. So mean deviation is basically that can be found out about a point. So it can be a point in the sense it can be about mean, it can be about median. So there are here 2 different cases in order to find the mean deviation. So the first one is the mean deviation can be found out about the mean or it can be found out about the median. So both cases are possible. So let's take it as a generalized pattern. So if the mean deviation, if we want to find the mean deviation about a point A, and the formula, the corresponding formula for the individual distribution here is mean deviation will be equal to 1 by n, the number of elements, the number of values. Sigma here it's a modulus. So modulus of x1 minus, xi minus a. So this is the formula for individual distribution. But there will be formula which is different here for in case of the discrete or as well as the continuous distribution. So let's see the formula for the discrete and continuous series of distribution here. So here as we know for discrete and continuous we'll be having the the frequency here. So here there will be adding the frequency and here the capital N will be coming in place of small n. So which means the mean deviation formula for, in order to find the mean deviation for the discrete or continuous distribution, it will be equal to 1 by n, capital N, which is sigma fi. Sigma fi into xi minus a. I is equal to 1 from 1 to n. So this is the mean deviation formula. So here is about a. So in this place we can have about mean or about median. So both cases are possible. Right. So let's see the first case, that is about mean and median for our individual distribution, individual data distribution. Right, so the formula we already know. So how we'll be representing the mean? So x bar will be the mean and capital M will be the median. So this is for the individual data distribution. Right, so let's see the formula. So the mean deviation here will be 1 by n sigma modulus of xi minus x bar. So this is the formula. So this is about mean. If it's about median, in place of x bar, we'll be having median. So let's see how to find mean deviation for this individual series, individual data distribution, about mean as well as median. So the first question is about mean. So read the question. So I'll just write down the formula here. So mean deviation is equal to 1 by n sigma modulus of xi minus x bar. I is equal to 1 to n. First thing is you have to find the mean. Because here we are going to find this mean deviation about mean. So here we have to find the mean of the given data first. So this is individual series. So how we are going to find the mean? That is x bar will be equal to 6 plus 7 plus 10 plus 12 plus 13 plus 4 plus 8 plus 12. So how many terms we are having here? So 1, 2, 3, 4, 5, 6, 7, 8. So sum of all these divided by 8. So sum of them will be equal to, so let's add up, 13, 23, 35, 8, 7, 72. So 72 divided by 8. That means 9. So we have found out the mean of this given data, which is x bar equal to 9. So now we have to find the mean deviation. Right. So in order to find the mean deviation, the first thing we have to find is the sigma of all these values. So let's find out that first. Let me erase this part. So x bar we have already found out, which is equal to 9. So now we have to find the modulus of xi minus x bar. Right. So that means first xi here is 6. So 6 minus 9 will be 3. So as it's a modulus, so we could take only 3. Right. So it will be 3 plus, as it's a sigma, 7 minus 9, it will be 2. 10 minus 9, it will be 1. 12 minus 9, 3. 13 minus 9, 4. 4 minus 9, it will be 5. 8 minus 9, 1. 12 minus 9, it will be 3. So we just have to do the sigma, because mean deviation is equal to 1 by n sigma I equal to 1 to n modulus of xi minus x bar. So we have already found out this xi minus x bar. So which are 3, 2 and all these values. So we have to find the sigma. That means 3 plus 2 plus 1 plus 3 plus 4 plus 5 plus 1 plus 3 divided by n here. So what is the n value? N is equal to 8. So let's do the sum here. 5, 10, 15, 19, 22. So 22 divided by 8. So it will be obviously in decimals. So 16.75. So here the mean deviation about mean for the given data, which is in the format of individual series, here is equal to mean deviation is equal to 2.75. So this is about mean. So we can find the same mean deviation about median also. So let's do one question about median. So finding the mean deviation about median. So let's do this question. So first thing is you have to figure out the median. So let me write down the formula. So formula will be same, 1 by n sigma I equal to 1 to n xi, whereas here in place of mean we will be having the median. So in order to find the median, you have to arrange either in ascending or descending format. So let's do that. So 3, 4, 5, 7, 9, 10, 12, 18, 19, 21. So I have arranged ascending order. So let's see how many number of terms. 3, 6, 11. Which means my n value is equal to 11. So find out the median value here. So it will obviously be the mid value. So 9 is the mid value from 5 and 5. So 9 is the mid value. So the median of the given individual data here is equal to 9. So as we have median now, so let's use the formula of the mean deviation. So that means equal to 1 by 9, that means 1 by 11. Now sigma, right? So xi minus m, that means first one 3. So 3 minus 9 will be 6. As it's a modulus, we can directly take the values, absolute values. So it will be 6. And again 3 minus 9, it will be 6. 4 minus 9, it will be 5. 5 minus 9, it will be 4. 7 minus 9, 2. 9 minus 9, it will be 0. 10 minus 9, 1. 9 minus 12, 3. 18 minus 9, 9. 19 minus 9, 10. 21 minus 9, it will be 12. So these are the absolute values where we have to find the sigma, that is sum of all these terms. So that's what we have to find, the sum of terms. So 6 plus 6, 12, 17, 21, 23, 27, 37, 47, 49, 49 plus 9 will be 58. So 58 in the numerator divided by 11. So now the mean deviation about median here is 58 divided by 11. So let's find out the value. So 5 times it will be 5.27. So the mean deviation here about median. So in the previous question, in the previous data, we have found out the mean deviation about mean. So now we have found out the mean deviation about median. So now here the answer of mean deviation will be equal to 5.27. So this is how we will be finding the mean deviation about mean as well as about median in the given individual data series. So we'll be having a different formula if we are having a discrete as well as a continuous series. So if you check, the mean deviation will be least when we take that from the median. So you can just give it a try for this. Here that in these two questions I have given two different data. So what you can do is, for this about mean which we have find, you can give it a try with median also, and for the second question which we have done with median, you can give it a try about mean. So what you can do is, you can take these two questions as homework. So let me do that thing. So the first question in class we have done this, finding the mean deviation about mean. So you just do the homework, find the same, for the same data, find the mean deviation about the median. Here for the first question. And in the second question in class we have done the mean deviation about median. So homework, find it about for the same data about the mean. And let's and observe the difference of the values how we are getting here. Right. So for the remaining two series, continuous as well as the discrete series, of how to find the mean deviation, we'll just discuss that in our next session of statistics. So that's all for today, guys. So if you guys have any questions, any doubts in regard of this statistics or mean, median, mode, as well as the mean deviation which we have done in our today's session, please let me know in the comment section, in the text box. And please do give it a try, these two homework questions, and you can just observe the difference how we are getting the mean deviation. Right. So that's all, guys. So thank you. So we'll just continue the rest of the topic